let's see. So what I want to do is basically let's go over these translate tools, because I think you need to learn. I mean, they might be a bit complex, but what basically translate does is, if you remember, we have a canvas, and this is our origin, 0, 0, and this is going to be kind of a width and height. So width and height is 600 by 600, right? And what translate does is basically translate this origin to a location. So when I write, for instance, translate width divided by height, width divided by 2, height divided by 2, this means translate 300 by 300. So this is that 300 by 300 vector, right? So it places the origin to the middle of the canvas, and then it rotates it, and then it draws a rectangle in place of the new origin. And that's what this translate does. Basically, this allows me to do a bunch of things. It allows me to control the origin, control the plane, the canvas plane where we can draw. Because, for instance, rotate actually rotates the canvas origin. So imagine that we have two vectors going up and down like this, right? So when I translate it, those vectors are translated here to the middle of the canvas. And then after rotate, this gets rotated in the positive or negative direction, right? So pi divided by 3 means pi is 180 degrees. So this rotates it 60 degrees. So it's a 60-degree rotation. I guess this would be, is it this way or that way? Let's find out actually. So let's do pi divided by 2. This will be 90. Pi divided by 4. This is 45 degrees, right? So it's, let's do pi divided by 12 or 18, which would be 10 degrees. So you can see it's actually rotating it in the clockwise direction, right? So this is kind of the new direction of the origin. So translate relocates the origin, rotates the canvas, and then rectangle basically draws in place on the new origin with the new rotated matrix. So all these operations are actually applied on the transformation matrix. So if you look at, for instance, rotate, it rotates a shape by the amount specified by the angle parameter. It could be done in radians or degrees. Objects are always rotated around their relative position to the origin. In positive numbers, rotated objects in the clockwise direction. Transformations apply to everything that happens after a subsequent calls to the function accumulate the effect. For example, calling rotate and then rotate is the same as rotate. Rotate pi. So this is like a cumulative operation. All transformations are reset when draw begins again. This is interesting, right? So basically, before this, translate is reset. So if I do something like this, for instance, let's actually try this out. Let's actually play around with this a bit. So width divided by 4, height divided by 2. As you can see, this is now a vector like this, because width divided by 4 is basically 150 in the x and 300 in the y direction. So I get a vector like this. So this is my new origin with the new rotation, right? So rotate we can also control with the angle mode. Let's find out. Let's make angle mode in degrees. All right, and what I want to do is make this a bit randomized. So let's do like this, fill kind of a random tone of red, random 60, 20. Let's move it to a random width, random width, and random height. I'm wondering if this would work. And rotate is going to be degrees. So random 180. And we're going to draw a rectangle. Let's see, let W equals random 20, let height equals random 100. So these are going to be like rectangles. And this is, what is our rect mode? Let's find out. Rect mode. Rect mode is basically how we draw rectangles, right? We can do a rectangle with the center. So that would be basically drawing, we will specify the center location and then width and height. So if we use this rect mode center, we specify how we're going to decide on how we draw rectangles. Then remember that translate actually moves my origin to a new location. So technically, wherever I want to draw, the center is going to be 0, 0, right? So this would be 0, comma 0. And then my width is going to be this new width, and this is going to be my height. So let's see what's going to happen. All right, so what is going on? Actually, basically, at every time the canvas is being updated, we are getting a new translation matrix. And the first thing the program does is it translates the origin to a new location. So we don't know where we are drawing yet. And we are rotating the transformation matrix by an angle amount up to 180 degrees. We are specifying a random width and a random height value between 20 and 100. And then we are drawing a rectangle, right? So now this is getting a bit complex. But let's actually make this a bit more interesting. So no stroke. Maybe we don't have any borders. That will be just shapes. Maybe we increase this a bit and increase this. And rotate, let's make it up to 90. And fill, shall we do it up to 250? All right, so that's basically what it's outputting. Let's make this up to 50. Makes sense? So I'm generating basically new shapes at random locations. And I'm basically transforming the matrix every time with this translate. And I'm rotating the transformation matrix as well and drawing a custom shape. Okay. Any questions up until now?
No questions.
No questions. That makes sense, right? So translate moves the origin, rotates the origin, and then drawing a custom shape. Now, what I want to do is make this interactive with the mouse. Now, we can actually get the mouse location using mouse X and mouse Y. So let me actually show you how this is done. I'm going to first comment this part out. And let's do stroke 0, which would be black. And I'm going to do line, mouse X, mouse Y, and 0, 0, or width divided by 2, height divided by 2. Let's see, line, mouse X. Oh, this is mouse Y. Right, so what it does is basically it's plotting a line from the origin to the mouse location. So we can always use the mouse X and mouse Y, which is updated, right? So wherever I put my mouse, it basically registers some value. And since we are not drawing over it, the background is only drawn in the setup. This is basically outputting on the canvas. But if I move this here, then it will be basically a single line following my my cursor, basically. Okay. So what I want to do is translate this information into a rotation. So I want to rotate an object or orient an object towards my cursor. Okay. So how do we do this? Let's actually first find out. Let's actually do width divided by 2, height divided by 2, mouse X, mouse Y. So if I want to have a vector, let's look at angle. angle between. So you can see there's an example here. Actually, you can see the vector, the blue vector is actually following my cursor. How is it done? We basically create a vector, mouse x minus 50, mouse y minus 50, and then we draw an arrow from the origin to this vector. There's also this angle between function, which helps us calculate angles. Basically, this could be vertical vector, or no, the horizontal vector. So this is the x direction, the red vector. There's an angle here, and it's basically outputting. And we also have this translate and rotate. Vector dot heading is what I'm looking for. So the vector, we can actually get its angle, vector dot heading, and use it for rotation function. So rotate basically helps us rotate an object, if you remember. So what I can do is I can do let v as my rotation vector. Let's look at here again. So mouse x minus 50, mouse y minus 50, right? So what I'm going to do is create vector mouse x minus width divided by 2 and mouse y minus height divided by 2. And what I want to do is rotate v dot heading. Is that correct? V dot heading. What I need to do is call this into a function as well. And then I can do translate. We can also do translate before that, translate to the width divided by 2, height divided by 2. And I want to draw a rectangle there. Rectangle, W20, height 150. And let's do fill 0. So you can see this is actually rotating it, but let's see, maybe we should do it horizontally, right? So because it's facing my cursor, but I want it to face my mouse, so I'm going to use the X value to orient this, and you can see it's now looking at my cursor, right? So what it's doing is I'm translating the origin to the center of the canvas. Then I'm getting a vector. The way I calculate the vector is basically I have a mouse X and Y location, right? So let's say my mouse is here at this location. So this is where my mouse is. And this is the origin. Width divided by 2, height divided by 2. So when I do the vector calculation, I'm subtracting from the X location this value. So imagine if my X is 500 and my width divided by 2 is 300, so I'm getting 200, something like this. And then this is basically mouse y minus height 2, it's something like this, right? So I'm calculating a vector like this. So the blue vector is what I calculate by creating a vector, right? And then I'm getting its heading, which means I'm getting its angle of rotation compared to the x-axis. So this is the x-axis. So I'm getting this alpha angle, and I'm using for rotation. So I rotate the transformation matrix so that I can draw the rectangle there. So whatever this angle is, that's basically reorienting my object. Make sense? So what I want to do is, let's do this to a multiple array of objects. Huh? How about that? Shall we do it? So let's do like an array of objects here. So to do that, I'm going to do for loop for let for let I equals 0, I smaller than 10, I plus plus, right? So I want to create 10 rectangles in the horizontal direction. So my width is 600. How do we do this? So let's imagine we actually did this last week as an example, but I want to create a row of objects here, let's say, and I want to have offset values from the size, but I can use it. I can calculate it basically. So let's say that if I want to create 9 objects, then my interval is going to be width divided by 10, right? Because I'm going to start by an offset value from the center, from the corner, and then I'm going to create objects like this, and their interval is going to be x as well. Sorry, let's give it another name, y. And then the last item is going to be here, and it's going to have an offset value as y. So if the location of the objects, if there are 9 objects total, then the interval is going to be 10, right? Because we start with an interval and end with an interval with the canvas. So it's going to space out everything uniformly. So let's calculate this. So let's call it let gap equals width divided by, also let's give it a number, let num equals 9. Gap would be width divided by num plus 1. And this is going to be my num. And let's first place the objects. So I'm going to do, how do we do this? So we could also use translate, right? Shall we do translate? For instance, if I do translate. But keep in mind, translate actually does the operation one after the other. So this would basically, I will be translating things using gap and height. Let's make it gap as well. Actually, not gap, but we could do translate here as 0 and gap. So move things vertically. Or let's do this like this. I don't want to confuse you more, but let's actually keep it simple. Then just draw a rectangle. Okay. All right. What happened? So we created 9 objects. We calculated the gap value, which is width divided by num plus 1. So width divided by 10, basically. Our width is 600. So 600 divided by 10 is 60. And I do translate gap gap, which means I basically move things horizontally and vertically using the gap value. Gap value is 60, so it creates a vector like this, right? So each time in the for loop, I'm moving an object diagonally, and that's what we are seeing. So these guys are moved diagonally. So let's calculate a vector for them. Let's do let v equals create vector mouse x minus, actually mouse x and mouse y would suffice here probably, because we are translating it to a new origin. And then we want to do a rotate here. Let's see what's going to happen now. Whoa. So what's happening? So basically, every object is applying a transformation subsequently, right? So that's why we're getting something like this. But what if we want to keep them in their current location and we don't want this operation to be applied cumulatively? Remember that when we apply translate and rotate, we are inside a for loop, so it keeps rotating objects and elements, right? So if I basically get a different angle from the first object, then the subsequent rotations are also being taken into effect. So we could probably use push and pop here. Let's actually look at what push and pop do. So push and pop basically break the transformation operations. So if I add push here, that will basically add the current transformation matrix, and then I can do a translation for that object individually. So now this would have to be I times gap, and vertically we're not going to do anything, so I'm going to keep it at 0, and rotation will be computed here individually for this object. So mouse X, mouse Y. I think this should work. And then if I do pop here, let's do, now all of these are taking individual calculations. Let's see, V equals create vector. So translate I times gap. Are these changing the angles? It doesn't seem like they're all facing to my mouse, right? So translate mouse X, mouse Y, because this has to be minus, oh, this has to be mouse X minus like this. Now we are talking, right? So now all of them are facing the cursor. And we can also add translate here. So 0, comma gap. Now we're getting kind of waves. How many objects do we have? 2, 4, 6, 8, 9. And the gap value is, so we have 9 objects. Oh, this has to be num plus 1 probably. Yeah, we start at 0 though. Why do we start at 0? Because when I is 0, oh, okay. So I times gap. So we have to start with gap probably. Okay, so that's 10. All right, so we have to do this. All right, now I think we are getting somewhere, right? So if I move the cursor, you can see that their rotations are changing. So this translate before the push, it basically moves my current translation matrix to this height value, right? So this gap value. So I'm only moving it down because I'm only giving it gap. So this is my gap, which is 60 pixels. So I'm starting from this line here. So I'm doing push. Basically, I push the current matrix. I translate an object. I find these origin locations. So that's what the translate does. Then I create a vector using the mouse X and mouse Y, but I subtract the location, the current location of the object. So I need to add a gap here too, probably. Minus gap. Let's see. Oh, this is gap minus gap. All right, so now all of them are facing my cursor and they're kind of waving, right? They're kind of dancing. So let's increase this information. I'm going to make them a bit shorter, 100 pixels and 10 pixels wide. So now they're kind of dancing again. What shall we do? Let's do, what is our gap value? So let's keep this as our gap value. All right, that's nice, isn't it? So now they're all looking at my cursor. So they're taking an effect. Maybe we should change this into a double array, huh? Shall we? So I can write another for loop here. For let j equals 0. We did this last week. J smaller than num. J plus plus. So now I can also iterate through like a double array. So now what I want to do is not translate it only horizontally, but also vertically, because my vertical translation was 0. Now this could also be taken with an effect on j. And I want to subtract from mouse y minus j times gap gap. All right, so let's see what's going to happen. So now we have a double array. That's actually looking quite nice. So let's see, num is 9. Maybe we should take this out. All right, that looks good to me. What do you guys think? Right, so it's kind of dancing according to the mouse cursor. And the cool thing about this is we can control num. So if I make this like a big number, like 60, ooh, that's too big. Let's do 20. And let's make this 2. All right, so I can control the number of elements, right? And I can probably use this to calculate kind of a gradient as well. Basically, all of these objects have different distances to my cursor, right? So I'm for the moment, I'm only giving them a black fill, but we could actually calculate the distance of these elements. So that's actually here, right here. The length of this vector could be the distance. So vector length, we have, let's actually look at vector function. We can get the area magnitude, right? Calculates the magnitude length of the vector and returns the result as a float. So if I do, for instance, let d equals v dot mag calculates the magnitude. And then what I want to do is use that d value as a coefficient. So let's make it, let's use another function here called lerp color. So I'm going to define 2 tones, like from and to, and then I'm going to lerp between them using a coefficient. And this coefficient is basically distance divided by what could be the maximum distance. So the maximum distance could be the diagonal length, right? So let's find out. Let's actually make this color mode. So I'll show you something else. Basically, we could do color mode RGB red, green, blue. And I can define these as kind of broader variables. So if I write them here outside of the function, not everything has to be written here, right? So if I write something here, if I declare this variable here, I could use it anywhere I want inside the program. So since I have the d value, now what I want to do is calculate, oh, sorry, I was going to do from and to. So let's do from and to. And I want to calculate a color and lerp color from to, and this is going to be d divided by, let's say 1000. And I'm going to do fill like this. And let's see what we get. Color is not defined. Cannot access from before initialization. Let's see, 112. Color is not defined in the current scope. If you have defined it, oh, color, we have to do color mode again here. Well, we do have it here. I guess it doesn't like defining color here. So we could maybe do it like this, from equals to equals and these could be my variables from and to. I'm using just the values I copied basically. The color mode is not defined. Why is this not defined? It's right here. Oh, I need to delete this line. Okay. All right. Now it's a kind of a gradient. Is it? What is this value? Let's make it clear. Let's make this 255, 0, 0. And this as green, 0, 255, 0. So we're going to interpolate between from and to using a coefficient, I hope. Well, the green is not too visible. So I'm going to do no stroke. No stroke. And my fill here, let's actually reduce this coefficient, 500. All right. Right, so if basically the object is close to where I am in the cursor, it will get a red tone because it's getting something, basically D value is getting smaller. So when D value is getting smaller, it's the tone is getting similar to from, which is basically color red. So this is red and this is green. And lerp color, what it does is it interpolates between two color tones. So it interpolates from to two, and these are this is kind of going from 0 to 1 or some sort of other coefficient. So we can pick nice two colors. So basically we could do yellow cyan if you want. So we could make this 255. Anyway, yellowish tone. And if I make this 230, this will be now as kind of a cyan. Right? And we get some green in between as well. And let's actually make this a bit wider. So let's make this 5. So the objects are rotating and they're also changing the hue. Let's make the background a bit darker so that we can see these objects. All right. Now I'm also going to change this value right here because we have D. I can also change this so that if I do let W equals lerp, lerp is also similar to lerp color, but this time I can have two values, let's say between 1 and 10, and I want to use D divided by 500 as kind of the driver, basically the distance to my mouse. I'm going to do this as the width, right? So if basically the object is further away from me, it's going to get thicker, but if it's closer to me, it's going to get thinner. Okay, so we created, yeah. Yeah. I'm listening, yeah. You can talk. Does anybody have any questions?
Sorry, yes, okay. Can we change the color also when you change the mouse way?
Yeah, we can, like I'm defining the colors basically. So the from color is basically the color
Maybe
that is closer.
random.
Huh?
But can we use the random in the color part?
Yeah, we can, but the problem of that would be this would flicker a lot because I'm doing this operation in the draw, right? Every time it's updating. So it's if I do it random, every object is going to get a different color. So I'll do it random here, but like fill random 255. Like let's give it a random red tone. Or we can just do it random 255. You see, it flickers because it's updated every frame. Make sense?
Oh, okay. Yeah.
This version is basically getting the color per object based on my mouse location. So it's updating it if I move my mouse. Okay, I'm going to stop here actually and see if you have any questions, but this is the code for today. You will of course get it. But yeah, I'll put some nice results. What do you guys think? All right, so this is the mouse location. Yeah, if I increase the amount of objects, like it starts to slow down a bit, because it needs to apply these like translate operations to a lot of objects. It tends to get slower a bit. But you can also try this with another type of geometry, like you don't have to do a rectangle, but something else. Now you know rectangular, now you know translate and rotate. Okay. So I'm going to stop here. If you have any questions, let me know, but I'm going to send out this code to you as well. So you can give it a look and let me know if you have any questions.